Okay, so now we should be recording um, on WeVideo. And what we have now is we're trying to produce uniform motion on a position time graph. And I basically asked you to get data down a ramp. So I need to put in some other columns here. So change in time, and that'll be in seconds. Change in position in millimeters. Now we could convert these to meters, um, but for the sake of this activity, we won't bother. Notice we can't see some things, so we have to go to wrap text. So I'm going up to the wrap text, and I move that. I'll adjust this a little bit. Okay, next columns, mid time, and finally velocity. Of course, the direction of velocity will be down the ramp, but I won't bother putting a direction here. I'll just assume it dot. So dot would be the numbers or the dots that I measured to. Some of you measured every other dot. Some of you measured every sixth dot. I decided to change my timing so it was for every tenth of a second. So if you don't want to keep typing all the numbers in, you can simply go highlight the two, go to the corner, and drag to your 10th dot. Now I'm going to drag to the 11th dot to show you what I did for mine. So my time is equal to the dot divided by whatever your rate was. My rate was 10 frames a second. Some of you might have 1 over 30 if you did every other dot, and some of you had every 6 dots, so that would be 1 over 10. If you did every dot, that would be 1 over 60, or the number beside it, the dot, divided by the number. So I'm going to format that I have as 1 decimal place and drag it down. If you did 60 frames a second, you want 2 decimal places. So let's just up it to 2. Okay, so position. The positions I measured on my data were as follows, and you'll notice a certain trend where at the beginning it doesn't quite look constant, and then it starts to become a lot better. 26, 2, 35, 3, 44, 4, 53.9, 4, 71, 6, 80, 88.6, and finally 96.4. Now I said for you to only go to 10 points, but there was a reason why I did the 11th point, and I'll show you just in a minute. Now I want to format them so they all have 1 decimal place, so highlight them all, go to the increased decimal places. Oop, that's 2, so now there's 1 in each. Change in time. I click on this cell, and I could actually show you the formula, but I'll show you the formula after I get all of them in. So equals the position in, or sorry, the time in B3 minus the time in B2. Enter, and now you can drag that down, and the change should be identical because the timing mechanism. Now, change in position is simply the position 2 minus the position before, which is position 1, and then we drag that. Mid time equals, we have to open a bracket, and we'll take time 1 plus time 2, close the bracket, divide by 2 because it's a midpoint formula, and then we go and we drag that down. And finally, velocity is defined as the change in position over the change in time using those two cells, and you need to change that to millimeters per second. Okay, so drag that down, and as you can see, it's, well, a little bit faster, and then it slowed down again. Now I might, that's what I was trying to see, if I was going to eliminate the end data and kind of replace it all and move these all up 1, but I'm just going to actually delete this entire row at the bottom. So delete it, and I'll just use that data. Okay, you want to see the actual formulas, I can go to data, and maybe it's a new view. Oh, that was data, and then, of course, now you're waiting on the video. Show formulas. Oh, it's in formulas. Yeah, they had it different somewhere else. Okay, so there's the show formulas, and you can actually see what the formulas were in all of them. Okay, so I'll just leave that for a second. Now get rid of that, and I'll go show you what the graphs look like. Okay, so I'm going to do a position time graph. So highlight position and time, and I'll go to insert, And of course, you guys have seen this before. I'm going to my scatter, and this, of course, is Microsoft Excel 2016. So the grid lines don't show up very well. So I'm going to move the chart, right-click, move the chart as a sheet, and okay, here we go. Okay, so then I'm going to put the plus because that'll allow me to add grid lines. So I'll click on grid lines, and I'll put all of them on. And those are the ones that we have problems seeing. So we have to click, right click, and then we'll format grid lines, and it should pop up over here. And we'll make them darker. And now, same thing with all of the grid lines. So keep changing the color. And some of you might have set a template already. Hopefully you did in your version of Excel. I tried to do it on the computer system here, but it seems that some of those settings are not kept. The Durham board basically resets it to default. So unfortunate. Okay, so I've adjusted that. I'll put on the best fit line before I adjust the scale. So I'll go add trend line, and I want to display the equation, display the r squared, and I'm going to fill behind that. So, oops, let's click there and find our fill, and we want a solid fill, and we want our color to be white so we can easily see it. So that's 0.9998, which is good. So it is showing some variation, but very little. It's almost constant speed. One of the things you notice here is I don't really need at the bottom of the screen to go down to a negative number. So I'm going to click on this axis, and I'm going to click on the graph axis options. That allows me to set the minimum. So I'm going to set the minimum to 0, and it says it's counting by twos. That's acceptable. So, but the other one that we have to check, because these aren't nice little boxes, they're kind of elongated rectangles. So I click on the other scale, and I see it's counting by 0.4. And I've said that you can only count by ones, twos, 2.5s, fives, or multiples up. So I have to change this number over here to that. And we'll see that's much better. Now they're little squares. One of the other things that's weird about this version is the actual trend line isn't very nice to see, so I have to adjust the trend line. I'm going to put it black, and of course I have to adjust the dash type. I'd rather it to be a nice solid line. Okay, so there is the one. The only thing that we have to change is the title, and the title of this is Uniform Motion of a plastic weight down down a ramp with a. That's a good question. What was the angle? I didn't measure it, so I'm gonna have to measure that. Put it in there. So let's just pretend. I'll maybe see if I can get it right. I'll just guess it's 10 degrees. Okay, so I'm gonna put. Oh, where's my degree sign? So I'll hit enter, and then I'll see if I can actually find where I can insert the degree. So there should be a way beside here. Yep, there it is, symbol, and I can find the degree sign. Close. So uniform motion of a plastic weight down a ramp with an angle of 10 degrees. Okay, and the other thing I have to still have is axis titles. So I'll go to design. Oh no, that's the plus sign on this one. So we have to go to axis titles, and there's the bottom one, the top one. So here's this one, time. Oh, I don't like that time. We maybe should change it so it counts for every 0.1. So we'll do that in just a second. So time in seconds, and then this one, let's change the counting. So back to this tick mark option. There it is. So the major unit, instead of 0.2, I'm going to change to 0.1. Yeah, better. And the only other thing that I need here is this axis title, and that one is position. And of course, it's position in millimeters, and if we wanted to put in the direction, we could say down Okay, so that's the position time graph done. One of the things that we have to do is we have to find the slope of the line. So we're going to use the corners of grid lines wherever the actual trend line goes through, and then we'll find the slope. And that slope should correspond with the value in front of the x in y is equal to 89.7. So that's the slope there. But the slope of your best fit line by doing it with a hand calculation should come up to the same thing. Okay, so going back to our data, and we're looking at mid time and velocity. So we highlight those two columns, and we're going to go insert, again, scatter, and I can see, oh, that's not as bad as what I've seen from some of the data in the class. So I quickly did it. I didn't do it any more than twice because I didn't want to waste time. Move chart as a sheet. Now, one of the things that I would say with you here is if you put a trend line that's linear across here, it may not be a zero slope. I'll try it. Add the trend line, and I'll say display equation, display r squared. Oh, mine's pretty flat. Not quite a zero slope. Zero slope, that number right here would have had been zero, but mine's pretty flat, so it's not bad. Many of yours you actually won't get a zero or something that's close to zero, which means your data is flawed. So that is going to be the problem. Now, one of the other things that you also have to do is, yeah, once you print this line that I have here, and it may be better to actually put this on by hand. So I'm going to leave this, but I'll look at it and then I'll have it like really faint. So then I can draw one on by hand. So it's a zero slope, but that's basically zero. I do want a 0, 1. So like I said, I'm going to draw it on after I print it as well. The one that I print though has to go to my very end number. So I can see 1 here. So I could go into, there's a way to draw on here as well. Don't know. There they are. So insert shapes. I could actually insert a line, and I could go along here and draw right across. The only problem sometimes with drawing lines on Excel is when you move them around and bring them into Word, they sometimes change. So it would be probably better to draw this line on by hand rather than to try to draw it on here. So it's kind of up to you. If you want to try that and draw the line on the graph before you bring it over to Word, you can. But like I said, the experience I've had is they move and then they're no longer in the correct place. So other thing that I wanted to do again was format my grid lines. So same thing as before. And also, of course, I have to check what the counting scale is. So format this and format the other way. And sorry, this is taking so long. I guess you could always play this. I wonder if this program, if Google Classroom lets you play it at double speed. That would be convenient. Some programs do, some do not. So, ooh, that wasn't good. Okay, that's one. Maybe it's here. Fill. Oh, there's the line. Okay, finally this line, and got it done. Now, like I said before, we have to check to see what it's counting by. So we go to the axis options. There's the counting scale. 0.02 is fine, but the other scale counting by 2, yeah, that's fine because it's almost squares. Not a big deal in this one. We're just going to find the area underneath the straight line. So literally taking where this one crosses the axis. So if we go up here, we're looking at 82, 4, 6, 8. Probably 89 is about what the value is. And you can see here that it's almost 89 when you look at this text box. So I'll just find the fill in the text box, solid fill, and now you can see that it's basically 80. Now instead of moving the text box, I'll move the line. Find the text box. No, move the line again. So one of my things that I warned you about is sometimes, oh, I'm still on the line. There, I'm on the text box. Okay, so I'm moving the text box out of the way, and you can see that it's basically 88 and a half. So 88 and a half, my line is drawn a little bit higher. So if you had to set 89, whatever have you. And if you look, that value, if you go across your whole scale, now I basically just multiply by 1, and that 88.5 or 88.4 should match the value in the sheet at the bottom in the last value, right there, 88.6. So if that value isn't close, then you've done something wrong. So I would have a very small deviation if I actually found out what 88.6 was, which is the real, minus 88.4. Okay, so the only other thing is I have to change the titles on this one, and then I'm done. So that's basically what you have to do for the two graphs in this ramp uniform motion